The calculus of mean girls.
Contestants, find the limit of this equation.
Calling somebody else fat won't make you any skinnier. Calling someone stupid doesn't make you any smarter. And ruining Regina George's life definitely didn't make me any happier. All you can do in life is try to solve the problem in front of you.
The limit is -1.
Oh, crap. I lost.
That answer is incorrect. Now, we are in a sudden death. If Miss Heron can answer this problem correctly, we have a winner.
Limits. Why couldn't I remember anything about limits? Limits. That was the week Aaron got his haircut. Oh, God, he looks so cute. Okay, focus, Katie. What was on the board behind Aaron's head? If the limit never approaches anything, the limit does not exist. The limit does not exist!
Does the limit not exist? Let's see. But first, let's learn about L'Hopital's rule. The guidelines to L'Hopital's rule are, if a limit of x is approaching 0, you can rewrite the limit by taking the derivative of both the top and the bottom of the original limit. To understand the rule better, let's look at an example. Here we have the limit of x approaching 0 of x over x cubed minus x. Now if we put in 0 into this limit, we'll get 0 over 0, which doesn't help us much. We can rewrite the limit now using the rule to equal 1 over 3x squared using the chain rule minus 1. Now this time if we put 0 in, we get 1 over 3 times 0 squared minus 1, which equals 1 over -1. So the limit actually equals -1. Now let's look at the equation that Katie Heron had to solve at our Math League competition. On the bottom, we can use the trig identities to simplify this to sine squared of x. Now we can rewrite the limit to equal the natural log of 1 minus x minus sine of x over sine x squared. Now that we have a simplified version, we can rewrite the limit using L'Hopital's rule. First, we'll take the derivative of the natural log of 1 minus x. To do that, you do 1 over what is on the inside of the natural log times the derivative of what is inside the natural log, which equals -1 over 1 minus x. Then we subtract the derivative of sine x, which is cosine of x. And now we take the derivative of sine squared of x, which is 2 sine of x times cosine of x, because you take the chain rule and multiply by the derivative of the inside. Now that we've rewritten the limit, we can actually simplify it one more step. The bottom half actually is a trig identity, which can be simplified to equal sine of 2x. So we'll rewrite the limit as -1 over 1 minus x minus cosine of x all over sine of 2x. Now we can finally put in the 0 and see what happens. -1 over 1 minus 0 minus cosine of 0, which equals 1, all over sine of 0, which equals 0. So it gives us the final answer of -2 over 0. Now, we are definitely confident in the answer that this limit, it does not exist.
Our new state champions, the North Shore Mathletes.
How do you like me now? You like that? Yeah, get some, get some!